Good morning, everyone. Thank you so much for coming to my talk. Today, I want to tell you a story that brings together two themes. The first theme is this idea of creating more diversity in technology careers. Here is a Wired article published in the last 2 weeks about how little progress has been made by major tech companies in creating a more diverse workforce. And the second theme that I want to talk about today is this world of end-user programming and how the combination of these two themes can bring our field closer to work toward new goals. Here's a quick outline of my talk. And first, I want to talk about the most important thing, and that is the people in this study. The first group of people that I really want to talk about is a group of genomic scientists and biostatisticians at the Johns Hopkins Bloomberg School of Public Health. This group is pretty typical insofar as they do a lot of data analysis, they study genomics, and they publish academic papers about their research findings. But something a little bit unusual maybe about this group is that they have also had a lot of success teaching massive open online courses, and those courses have been about data science, genomics, statistical analysis, and their other areas of expertise. So this group created an educational program that I'm going to tell you about in this talk. And so in order to learn more about how they created this program and in order to flesh out this case study, I conducted 1 hour semi-structured interviews with each of the 9 members of this team. Like I said, this team had significant experience building massive open online courses, but in their own experience, and as it has been widely reported in the academic literature and in the popular press, they were dissatisfied with who their online courses were reaching. They traditionally were still reaching folks who had access to other forms of higher education, folks who could afford traditional educational opportunities, and MOOCs were failing to reach populations that historically have not had access to higher education, and especially have not had access to technical education. P1 wondered out loud in one of our interviews, why aren't certain groups of people using our existing online courses? Maybe they didn't have access to hardware, maybe they lacked requisite knowledge, or perhaps they were unaware that data science and statistical analysis, the fields that they were teaching in their online courses, maybe they're just unaware that that was a thing, meaning like a possible career path for them. So I want to switch gears for a little bit and ask if anyone knows what this map is. No? Well, I'll tell you. This map was created in 1937 by the Federal Homeowners Loan Corporation, which was a federal government agency that gave out home loans to folks. And this map illustrates the practice of redlining. Redlining meaning the process of denying access to financial or other services based on racial segregation, and in this case, racially segregated neighborhoods in the city of Baltimore, Maryland. So as you can see on this map, there are actual red lines drawn in the neighborhoods that this loan association was not willing to give loans for. And this kind of systemic and institutionalized racism still has effects on these neighborhoods and on the city of Baltimore today. And as you can see, redlining still affects Baltimore today. The arrow on this map is pointing to the location of the Johns Hopkins Bloomberg School of Public Health, which is located inside of one of these neighborhoods in East Baltimore that was affected by redlining. So this team at Johns Hopkins wanted to do something to help their local community. And now I'm going to talk about how they expanded educational opportunities in their neighborhood by repurposing end user programming tools. So the first thing that this Hopkins team did was that they partnered with on the ground organizations. So they had some existing relationships with the historic East Baltimore Community Action Coalition, or as they call themselves, HEBCAC, and that's how I'm going to refer to them for the rest of this talk. And HEBCAC is an organization that helps adults get their GED if they didn't graduate from high school. And it also works with adults in the East Baltimore community and employers in the East Baltimore community to set people up with jobs and job training. So here is an overview of the educational program that this team at Johns Hopkins, or as I'm going to refer to them, the CBDS team, this is the program that they built, which they called CBDS, which stands for Cloud-Based Data Science. So all these course materials are available online. Members of the CBDS team met with students in one-on-one tutoring sessions for 90 minutes every week. And tutors were also available all week in a private Slack channel in order to discuss the different topics that were being taught in these tutoring sessions. And they built this entire data science program in a few months at a fraction of what it would cost to normally develop a data science program. And as you can see, they teach skills like R programming, version control, and data analysis. So the question is, how did end user programming enable them to build this program? And mostly it was done through repurposing tools and skills that they already had at their disposal. And this repurposing was necessary because this program was not a part of their regular job responsibilities. It wasn't part of their regular genomic and statistical analysis type of work. One of the first concerns that the CBDS team had to deal with was the fact that computer hardware costs were really prohibitive to their students. A lot of them didn't grow up with, a lot of the students didn't grow up with a computer at home. Many of them did not own computers as adults. And so what the CBDS team did was they bought Chromebooks for each of the individual students and gave those Chromebooks to them. This also helped the CBDS team because, as I said before, building this program wasn't a part of their regular day job. And so they needed to, they were operating on kind of a bootstrapped limited budget. And Chromebooks are relatively cheap compared to other computers out there. And providing students with Chromebooks also made the CBDS team think about what kinds of software choices they were going to make in terms of setting up a data analytics software environment for their students. So they decided to put everything in the cloud so that students could log into a common data science IDE called RStudio through their web browser on their Chromebook. So that way there were no software setup there were no software setup concerns for the students that they had to deal with on their own individual computers. As I said before, this team, the CBDS team, already had significant experience building online courses. And they built those online courses in the past on the Coursera platform. And the Coursera platform didn't really fit in well with their normal data analytic workflow. You can see P1 here said, the way the Coursera platform is set up, it's not as simple as push to GitHub, which makes content updates difficult. So in teaching technical subjects, the members of the CBDS team already had experience from their online courses that, a software library that they would be teaching would need to be updated. They'd then have to go to Coursera and click around inside of their GUIs in order to update each time a particular function was mentioned that had, its arguments changed. And this was a really time-consuming and unproductive task that had to be done frequently whenever a new piece of technology got updated. the world that the CBDS team is used to working in is this world of end user programming. So as you can see here, they have this is a screenshot of RStudio. On the left, it shows an R Markdown document. This is kind of a plain text document, somewhat like a Jupyter notebook, where you can write prose and also R code, and you can compile that into web pages, into data visualizations. You can even compile it into the correct journal and conference paper formats, which the CBDS team frequently did for their own academic publishing. And you can also compile this R Markdown format into slides if you would like. So they were really used to this workflow of having everything be in plain text and then compiling it to some richer format. And so they wanted to do the same thing with their online courses. So what they did was pretty remarkable. They called up LeanPub, which is a company that publishes ebooks from plain text documents, and they asked LeanPub if they would build them a MOOC platform in the same spirit, where you build a MOOC completely in plain text, and then you upload those plain text documents to LeanPub, and then it renders those plain text documents into online course materials. LeanPub loved this idea, and they built this platform first for the CBDS team, and then they've released this platform so that anyone can use it. So this fit in much better with the CBDS team's regular workflow, where they would write our Markdown documents in RStudio, they would push and pull from GitHub, and in that way they could collaborate with, the team members could collaborate with each other, and then finally they would upload all those materials onto LeanPub. And as you can see here, P9 says, making the fact that all this content was in plain text made making changes super easy, and it allowed them to adapt pre-existing materials that they had in their lab, explaining data analytic workflows so that they could be used in these courses. So here's a screenshot of the LeanPub platform. As you can see, they kind of have course navigation and quizzes on the left, and then some like actual class content on the right. So it's, they created a pretty standard MOOC platform. Another big challenge that the CBDS team had was making these MOOC videos. So they knew already that creating these technical videos is actually quite expensive. As we all know, professor time is essentially infinitely expensive. And then there's time to edit the videos, and setting up the whole production is a pretty expensive process. And so every time some API would change in a software library that they were teaching, they would have to go and edit a new video. And so this video editing process was a very bespoke process that required a lot of human hands touching it in order to make the relevant updates to these videos. And it was very much unlike their typical workflow, which is completely based in plain text. In order to more efficiently create technical lecture videos, the CBDS team built a software package called ARI. So ARI allowed them to create lecture videos from R Markdown documents. As I mentioned before, R Markdown documents can already be used to create lecture slides. So what the team members would do is that they would create these lecture slides, and then they would write a script to be read over each of the slides. ARI would then use a text-to-speech API to synthesize computer-generated voice to be read over each slide. And then the ARI software package would stitch together this audio narration and each individual slide into a lecture video. So now I'd like to show you a short clip from one of those videos.
To get started, you'll need to be sure that the tidyr package is installed and loaded into your RStudio session. As data are often stored in wide formats, you'll likely use Gather a lot more frequently than you'll use Spread. This will allow you to get the data into a long format that will be easy to use for analysis. In tidyr, Gather will take the air quality dataset from wide to long, putting each column name into the first column and each corresponding value into the second column. Here, the first column will be called key. The second column will be value.
So finally, in order to pull all of this workflow together, the CBDS team built an R package called Didactar that could automate and help check their entire workflow. So as you can see here, this is a basic illustration of their workflow. So they created all of these plain text R Markdown documents, including the slides for the lectures and the script that would be read in the lectures. That produced a video, which then was combined with readings and assessments, which were all written in R Markdown. So Didactar would pull all of these together and it would test them and make sure that they were ready for release on Leanpub. So finally, I just want to talk about some of the outcomes and implications of all this work. And of course, probably the most important outcome is the students who have gone through this program. So here are some photographs from one recent graduation from one of the cohorts in CBDS. About a dozen students have gone through the program so far. And what happens is that CBDS and HEBCAC both work together to help these students prepare their resumes and to prep them for data science type interviews. And then they set them up with entry-level data science jobs in the area. And, this is the easily the most important part of the program, is producing new students, opening up these opportunities within the East Baltimore community, and providing these educational opportunities. I also want to talk about, and I'm interested in your reaction to this idea of courseware engineering. So what the CBDS team did was they used, they adapted their regular workflow and turned it into sort of a platform for technical education that facilitates refactoring, which is something which is necessary considering always updating and changing software libraries and programming tools. And most importantly, this builds on workflows that they already had in place and ways of refactoring and updating that they're already used to as biostatisticians. And I also am interested in your reaction to this idea of end-user programming for social good. The CBDS team was composed mostly of academic data scientists, but in the end, it wasn't their data or research-related skills that really allowed them to build CBDS. Rather, it was their ability to design this workflow, and the workflow therefore enabled really rapid collaboration and iteration between the team that was building this program, so that they could affordably and quickly put together these course materials, and it was all facilitated through end-user programming. So thank you so much for your attention today, and I would be happy to answer any questions.